My intent is to finish this Proctree implementation today, or at least to finish the nodes that the functions that I actually need out of it. So yesterday, I finished the basic setters for inserting nodes at location and depth, inserting a node at a normalized location and depth, inserting a node at a path. And today I created insert point cloud at location and depth and insert normalized point cloud at location and depth. So basically, all the setters are done. So what I need to do is I need to write the getters. And in particular, there's certain getters that I care about. Like, I don't care too much about get node at depth containing point or get node at depth containing normalized point or get node at path. All those are kind of not super relevant to what I want to do with the tree, but get nodes at depth from node and get nodes in depth from node are both very important for what I want to do with the tree, because those are related to actually like searching the conceptual space. And then the other thing that I want to do is implement the first pass at the randomization core randomization on the nodes as they get inserted, or specifically as the intended node gets inserted. Like, I don't need the randomization cores on parents unless the parent is intentionally intentionally wanting to contain it. So what I'm gonna want to do for that, I gotta think about it. But first we can just go ahead and take a look at these two functions, because these are going to be the most important. They're both very similar. Actually, I don't know if I want the activation to be part of it. Like, I'm sort of thinking that it should be managed externally as far as the randomization cores go. Like right here, I could do this. And this is probably a little out of date. Like this right here should be derivative from the insertion point if it's getting inserted that way. Okay, well, I'll have to think about that. Maybe we just always activate the randomization core for any nodes we insert. What if I just always add the core? I wonder how much that slows down our insertion process. I mean, it's at the bottom of a big call stack, so it might. So to test that, we can go here. And I have some of these methods that I've been building where I've been testing it. So this creates us a max depth node that we can play with. And then this allows us to traverse up to grab a parent of that node. And then I'll just change start coding. And then the toString is just a handy thing. The for loop is basically generating a point cloud and inserting it. So if I run this, how much did that slow me down? It slowed it down a little bit. So that was the amount of time it took to insert 10,000 entries into the Octree at a given depth. And you can kind of see what ends up happening based on the depth that the cloud was originally generated at. It kind of stays within the bounds of whatever parent that was. It's 10,000 nodes, so it's a lot. I don't... So like right now, I'm not sure how much of that delay was the print statements. Actually, probably a lot of it. Yeah, it was much faster. And we inserted 10,000 nodes in a couple seconds. No, less than a couple seconds, maybe like less than a second. That's pretty good. That's a pretty good throughput. If I bump it up to 100,000, 1, 2, 3, 4, 5, 6, 7, about 7 seconds to generate 100,000 points. Alright, so let's turn it back down to a manageable number here and reconnect the print. Still kind of in the process of self-checking all this shit and verifying that it all works. All right, and this is where we can kind of check our math, right? So if we have a center here, and our size is this, then our bounds would go this much in either direction from here, and it looks like they're staying in that range over here. Likewise here, we shouldn't see anything more than 120,000, anything less than like 0, and we don't. And same over here, and we don't. So it looks pretty good. So next, we need the logic to search, to basically search out the nodes that we've inserted now. And I gotta think about how that's gonna look. So let's start with get nodes at depth from node, because this is a fairly simple use case. This is going to take in an Octree node. It's going to take in a depth. I might need to look up some stuff on writing this. Or not look up, just ask coworker. Hey coworker, how do I get any nodes at a specified depth from a given node? Oh, whoops. Coworker's dead. Alright, coworker. Let's go. The provided depth will be relative. I don't want return all the nodes at their depth. I only want to return the nodes are children of the descendants of the node. All right, let's take a look at this one. That's wrong. It's definitely wrong. Traverse tree. Oh wait, maybe not. Yeah, okay, it's fine. Yeah, so like we don't need to check this, for instance, assuming we're traverse tree if node depth equals absolute depth in the node for child node and node children. Child node is descendant, traverse tree. So first let's just do this. How can I do that without recursion? stack. Proctree node. Array. While loop. No. No. Oh, the stack's not empty. Do we have a stack type? We have a set. Would that work? What are my options on a set? Yeah, has to be an array then. And we just have to make it work under that framework. Children. Values. Temp node changes to a single. if the temp node is at the given depth, so greater than or equal to the absolute depth if that's true, first of all, we can go ahead and do this. Okay, so the first thing we do is we store the node we're working with from the array in a temp value, and then we pop it out of the array here. Move. Remove index. So we're always working from the top of the stack. Okay. Now, if this is true, we want to get our return stack and add the node. And if this is false, we want to take hold up, this is all jacked up. This goes here, this goes nowhere, this goes here, then here, and then this can come over here. I think that's right. If it's false, we get the values of all the children for each, push them into the stack. Insert all the children, and then we iterate. And then when all that's done, turn Proctree node array children and push the return stack out through it. Does that work? I think that's how it's supposed to go. Alright, so what do we do? Normalized location and depth. Depth is 7. Now we want to do a get nodes nodes at depth from node. Seven. For each two-string print. String fetched nodes. And if this works, I might stop with this because this is like important but not extremely fun. I kind of want to do some planet textures too. A little bit more fun. Let's give it a shot. Okay, so obviously we have an issue. So now we just want a breakpoint. Let's set a breakpoint here. Toggle that breakpoint. Go. Damn it. That makes sense. See exactly what it was too. After I can't call this get again. After I've removed the index, you have to operate on the temp node because obviously the get will not return anything because it's in the middle of removing it. There we go. Now we're talking. Did we work? I think it might have worked. Okay, so that's interesting. It's definitely iterating too many times. However, let's see. We insert 10 nodes. How many nodes did we finally conclude with? This is the one that's along our parent path that we spawned. So we should have 10 other nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Interesting idea that I have 11. Alright, a couple other things. I don't want it to always generate the cores actually. Insert node. We'll have to figure out how we want to deal with that. Alright, so let's go look at our testing harness here. So how are we doing this? We insert a node here, get the parent, because the for loops are inclusive in this shit, and that's the reason. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then this node is expected because this is in the. So we're spawning a node at 0, 0, 0 at the very bottom of the tree for our user to start in, and that node will have a parent chain all the way up the tree. And that's what node we're crisscrossing here, which makes sense. It absolutely makes sense. So now if I were to do a bit more, what kind of performance do I get from that scan function? It's not too bad. It's not too bad. It's going to be hard to verify because there's no way to guarantee that. Okay, for one thing, I have a loop body connected somewhere. Yeah, that's why. That's why right there. Alright, let's try this one more time. If this works, I'll probably call it quits on Octree stuff for the day and just do fun material shit. I think we're good. Again, I have to assume, because it's hitting the right number of nodes, it seems, that these sets overlap. I'm not going to like hand check these numbers. Alright, so basically this is going to form the core of my proceduralization scheme. So it's a really important, but also it's really important bit, but it also gives me a headache just trying to think about it. Actually, it gives me actual brain pain. My brain just no big enough. My brain no big enough to do this. There we go. Alright, so we got our getter function, the one that we would use the most anyway. There's another getter function. In depth from node, it's going to be just like, I'm actually going to delete this, copy this, paste, duplicate. At depth, in depth, indicating that we want all the nodes, including the parent nodes that we traverse, instead of just the slice at the bottom. And the difference there is that it actually makes it simpler. If this is greater than or equal to the given depth, then we insert the node. Yes. If it's not, then we insert all his children onto the stack, but we also still insert the node. That's the difference between these two functions. And it's not quite 100% yet, because there's actually another caveat. So the caveat being that we actually only care to insert the node if a randomization core is present on the node. But I haven't done my randomization core implementation yet, so I don't want to add that because it would break my ability to test this stuff at this point. But basically, at some point, instead of inserting a bunch of nodes and just inserting tree nodes, they all have a add core function that will generate a randomization core. Right now, that shit's just random, but I want it to be derived from the path to the node. So what does that mean? Well, it means eventually, when we do these search functions, we're not going to care to fetch every tree node, because if it's just a tree node, it could be like a parent and be not populated. It could, like, conceptually not be populated by anything. But if there's a randomization core present, we're going to assume that it is populated by something, and then we do want to return it. And so, with that said, didn't I have one other? Oh, we need to test this. This would be get nodes in depth from node. And our depth is still 7, because that's the depth we're populating here. Or no, here. And then we can just copy this whole thing. And this isn't quite done, because like I said, you still need to generate the randomization cores for your nodes that are actually populated. But this will at least tell me if my shit's working. I think it's working because it churned like a motherfucker. Yeah. Seems to be working, given that our path here is always the same at this point, but we also have all the other paths from every point under that point. Does seem to work. Okay, cool. So part of the reason I haven't implemented the randomization core functionality yet is I'm not exactly sure which paradigm I want to go with. So I could go with like a point cloud insertion and then just generate randomization cores at my desired level for the point cloud, but that has some issues with it. Mainly that if I generate the point cloud in the same node every time, then it'll always be the same point cloud. But if I offset that node, and I have a node that like overlaps it, and I generate a point cloud in the center of that node, it's not necessarily going to be the same point cloud, and because of that, you got to be very careful with how these things instantiate, because any element that finds itself at a position in the tree should mathematically always be in that position. As soon as you look at that node, you should know, okay, because of the seed of this node and this randomization values, this will always be populated, and the other one won't, or something like that. So another option is you could run a function along the lines of like a populate, where you populate the children but you don't fill them with randomization cores. And you could do like a sparse, like you could have like a density that you populate the points at. So you just go like, I say I want to populate a given node down to a certain depth at a certain density. And I go through each of its children and I populate a random number of nodes centered around the density. And I populate like the whole depth like that. And then when you generate your randomization cores, you could run them through, like, you could get that set, that populated set of nodes, right? So now you have a set of nodes uniformly or randomly populated at a specific density, and then you could take those nodes and you could take all the randomization cores from them and you could run them through a distribution function and basically kill ones that don't meet the qualifications of the distribution function. And if you do that, then you can control not just the point cloud, but also the shape of the cloud. So you could feed it just a function, takes in XYZ and a given node and the randomization core for that node, and then determines based on the randomization core values and the distribution function if that point is going to be populated or not. And if it's not, it will strip the randomization core out, and then you have your points. So I'm not 100% sure how to use this structure yet, but I do think that this is going to be a useful tool to basically procedurally generate a bunch of shit. It seems to be working as expected here. There's a while, like, this is literally just like a data structure. It doesn't do anything yet. I haven't wrapped it or provided any additional functionality or anything like that. So there's a lot of work to be done, but it is cool that I have it working. There's one other issue I ran into, is that if I make this the size that I want it to be, the depth that I want it to be, I actually I run into an engine restriction. Apparently when you nest recursive objects, so if I have like a tree object with a parent and children, and each child has the parent as the previous parent, when you start getting into the it seems to be, I know 50 levels down will do it because I tested it, and I'm on 40 now. You hit a naming size restriction where the name that it's internally using, it's composing of itself and all its children, and you hit an issue. Like here, I can do it right now actually. If I go to Proctree node and I go to my max depth and I manually set it to 60, or I'll see 50, and then I go to my testing module and I change the depth to 50. Now this might work might not. Okay, it worked there. And I think I know why. And I believe I know why. I believe the reason why that worked there is because I have this method get parent at level, and all my randomization is based on, like, if you can conceptualize an octree in your head, and you're at like a small node, every node you go up the tree is going to double in size around you, right? So the idea of this whole scheme is that instead of randomizing the whole tree to generate your whole universe, you track the user's path to the root in the tree, and then you select certain levels to generate point clouds at, and then decompose those point clouds at lower levels. So like the level you generate the point cloud at defines the bounds of your point cloud, and then the level that you decompose your point cloud at determines the size of your individual points, or at least the non-modified size. So like there's a size offset scalar that gets randomized in the randomization core that you could use in conjunction with the Octree node to determine the size of the object that you're randomly generating there. But I believe that since I'm going up 15 levels from 50, that I'm still high enough in the tree when I'm doing all this math that I'm not hitting that that recursion restriction. Seems to be working pretty good right now. So I guess if it's working, then it could have also been just a bug in some of my code that got incidentally fixed as I was fixing other things. So let's crank this puppy up and really run it through the ringer here. Seems like. Wait, I'm still at depth 40. Temp node. Oh, because okay, stop. I know why. Because the reason that's happening is because my initial insert here is happening at 50. I guess it got incidentally fixed. I guess I was just doing something wrong and didn't realize it, because right now it's not having a fucking problem at all. We're 70 nodes deep with an octree the size of the observable universe, or even larger. I initially started with the intent to do a leaf node of 2 size and a depth of 100 to give the ability to represent a space much larger than the universe if desired. Seems to work. Interesting. Now, if you ask me why this fucking works now and it didn't work then, I have no fucking clue. Also, I'm not entirely convinced these paths check out, although it is possible. Especially when I'm generating my point the way that I'm generating it right now. But I have another, so like, the reason it's possible is because I'm putting a node at 0, 0, 0, 0, which would produce, probably, you could expect it to produce like geometric patterns because it's like a so I have another insert methodology that we can use to randomize that and truly test it. We'll do insert node at path and Generate random Octree path, size 80, access 100. Pipe that in here, this into here, this right here, this right here, and this right here. And what that does is that instead of just always putting my path to the player's leaf node at 0, 0 in relative space to the Octree, now I'm generating a completely random location for the player to start. And so if it works correctly, we should expect to see not long chains of 4s, you know? Hey, look at that. That's more like what I was expecting to see. And you can see this num cores value. That's just indicating that like I'm not instantiating any of the randomization cores on any of this shit. Hey, we got a procedural generation Octree. Pretty nifty. Pretty cool. You can also see the size of the nodes growing geometrically as you, or shrinking geometrically as you get down to the bottom. Another thing I realized, with the help of Coworker, ChatGPT, my new coworker, is that if you just, I wasn't interested in an Octree for decomposing 3D space. It has to do that, but in a kind of a different way than most people use an Octree. So I don't care about the relative size. Like the Octree is just a conceptual data model for this stuff at the moment. And because of that, we can set our properties of the tree to whatever the hell we want them to be, as long as it's convenient. And what I realized is if you set your leaf size to be statically defined as 2, then it turns all your center points and all your sizes into integers, which is just nice. It's nice for math. It's nice for working with the data. And all of our randomization cores calculate a potential offset and scale anyway. So if you have your normalized tree node that's always at a given location, integer defined space, you can still multiply that by your offset and scale values to get a non-integer uniform location for your given randomization object. You know, what's fun is if we look at the root on this, we can see how big it is. We have a nice handy toString method that I wrote for these nodes for debugging purposes that has this print output thing, and we can take a look at our top level node and we'll know how big 100 order Octree really is in conceptual space. Spoilers, it's fucking big. It's actually probably overflowing the range that a float can represent. Most likely, I think. Which may mean that I need to calculate my size in my locations in 64s. But there's a problem with that. To do all the math for inserting this shit, I have to do a bunch of complicated math functions on my values, and those math functions are not compatible with N64s. So like, there's definitely some hurdles to overcome here, but this is a really, really good start, I think. It's also fast. So if, say, like the most time that's being taken here is the actual like output, the like string output. But like if I say inserted 10,000 nodes at the desired depth, we churn. It didn't take too long. it does kind of look like it fucked up some here. The problem that I'm also running into, I believe, is that, yeah, like, we're probably overflowing the value of the max value of float and all the math that we're doing for this. So it may be a situation where I'm just forced into using multiple octrees to represent like very large, medium, small, or something like that anyway, because I simply, the math inside the octree explodes when you make it too big. Alright, so, good progress on that. Now I want to do something a little bit more fun. I don't know where this is. I wonder if I get a message in the log when I overflow the bounds of... It doesn't look like I do. Also, it looks like I'm just fucked here. Can't do anything. Damn it. Heyo. There we go. What was I trying to do before? I had where did I build that fucker? Cancel. Hold up. Just close all this stuff for now. So I had a procedural somewhere in one of these. Don't save. No, it's not here. Portal? Oh, for fuck's sake. Probably need to shut the whole thing down and bring it back up. There we go. Okay. I started working on this geometry script. Read this. We got our skybox game looking pretty good, I think. So, I have this geometry script here. And I'm working on some material for it. I also think you can probably do proper, like, space to planet tessellation using the geometry scripts. I'm just too fucking dumb to do it. Or not. That may be a little unfair to myself. It's not that I'm too dumb to do it. I just haven't invested the time it would take for me to know how to do it. Now, the fact that that would be a lot of time is beside the point. I think it's like, you know, definitely one of the streams this weekend, it's time to just put some shitty background music in the game. Just some shitty space music. I could generate it with an AI, like it's no big deal. Like, I don't have to write the music. I just tell a robot to do it, and it'll work just fine. Like, look at this. This shit, like, oh man, we about to enter some interesting times. It's like a... It's like a Chinese proverb, I think, or something that translates to, like, when you want to tell somebody, like, politely, fuck you, you just, like, may you live in interesting times. But yeah, this robot shit is gonna fucking cause all kinds of interesting shockwaves in the world. Maybe just like... No, that's too fast. Here, let's try these. I haven't actually listened to them yet. That sounds kind of like space music to me. Too much of a beat. I think I need like synthwave. Yeah, there we go. And just crank it. Way down. That's perfect, actually. And just have that beat booping in the background. Alright, so this guy is cool, and it's actually a great opportunity because I've wanted to learn about this shit, and I need it for the nebulas to be really cool, the volumetric ones. And it is somewhere. There it is. It's pretty easy to do this. It's a geometry script, and we can... Alright, let's say that. Whatever. And we can... so this guy has this frozen shit. So right now this is really slow. Oh god. It chugs, it chugs, it chugs, it chugs. Like, it literally just screams. But you can put it back where I want it, and put this back where I want it. And then I can grab this guy, and if I click this, frozen, it starts running faster. Now it should run pretty good. And that's really fucking useful, actually. And then obviously this needs a better material than just orange. I was experimenting around with trying to create a dynamic texture at runtime and then trigger the geometry script off the dynamic texture. Because if I could figure out how to do that, the possibilities for that are actually crazy. If you can generate like a dynamic height map at runtime from like textures you generate at runtime, then like going down to the surface of the planet can become done with like basically a fractal. All right. All right, all right. How do we want to start a planet? We run Heitler. That's cool. And let's, I mean, the first thing that we can do is just oh, it's slow. Come on. There it goes. It's so much more pleasant messing around with materials and like objects in the viewer than it is face smashing on an Octree for 4 days. All right, great. It's kind of cool. Okay. Just do. So the thought that I have is that you could run. Damn it. Minus. Let's start it off like this and like this. So with this, we can take the output mesh from that. Obviously, it looks like crap right now, but we can take the output mesh from that and then use world height offset on it to mush it around again a little bit. I'm pretty sure that there would be a way to use geometry scripting to do like the LOD transition for this, like, cause you can cull like half the sphere at all times, and then you can also cull. You leave all this stuff at the resolution it is, but you get like a little box, and you put another, like a decal on top with faded edges, and you get high resolution textures, but you have to be able to change that shit around at runtime to do that. I think. This is still too big. There we go. Oh, Jesus. I wonder what that looks like, actually. I'm sure it's going to look bad, but I do kind of want to see it. No, looks done. Get rid of this. Alright, so obviously not super impressive with just 2 colors, but it's a way we could blend biomes, potentially. I need to. I'm going to, so. Can I have another? And if I can figure out how to use the virtual height field mesh shit on this, or figure out how to use the parallax occlusion mapping, you could do a better job than world height offset for the details of the landscape too, probably. But it's a start. I still think the noise resolution needs to come up. And then I wanted to test this. Oh, okay, wait. So like by the time you're hitting like right here, you would be like starting to reload shit. Shit, it's like I've got it in other materials somewhere. to multiply this by something is, oh, I got it. I think this was it. And it should also be this. There we go. That's what I wanted to see. Nice spiky planet. Ugh, I can't move. Planet, this mesh is too dense to be in my scene if it's not going to be a nanite asset is the problem too. Okay, so if that's the case, let's turn him off and let's try a different strategy. Oh, I know what I can do. I'll just go here. I want these. We can turn that off. This and this. Yeah, I'm gonna create a sphere. It's gonna be that long. I'm gonna max this shit out. It's gonna be pivot center. Add that. Accept. Content drawer. Actually, do it from here. I do. Alright. And then content. Name. And I'm gonna, actually this is fine. actually, for it to be here. And I go back to selection map. So now we should have a pretty dense, or not so dense actually. Oh man, that's a bad mesh. Holy shit. Why did it make that? Terrible. Is that... Yeah, that's terrible. Okay. Oh, I see. Oh, that's crazy, dude. I see. Now I understand. Can I subdivide this sphere further? It may choke on this as possible. So now I should be able to get even smaller. Okay, cool. That's insane. Oh. Fair enough. Fair enough. I am running magic as well. So I got in the top 1200 Magic, just fucking shitting around with it, and now I got the tournament playing for the qualifier. Play a game real quick. Win a quick game of Magic. Alright, so what happened here? Wireframe. Okay, that's sick. Now, materials. My project setup in this project is completely fucked up. I need to fix all these folders. I just kind of went willy-nilly all over the place doing stuff. Oh, it's preparing shaders. I see. Alright, well. It is doing some form of world height offset there. Hold up. Gameplay. No. Graphics. Yes. Here, I wanted to bring this over here for a minute. So I could play some of this. I've been grinding on this Unreal still. Helping myself. I just won a game in a funny way a second ago. This hand's insane if I draw a way to get hammer. And really shitty if I don't. Alright, well I gotta keep this. So if I draw a hammer next turn, this could potentially be a turn 2 kill hand. Maybe. I mean, if I draw a hammer, probably. Oops. Scamp goes first, because Charger can come later in the game with haste. Okay, he's on Panza. Panza. We really want a hammer. A hammer just wins the game. Fuck. Not great. Oh man, I'm not used to playing this shit in a window. Next. And I think I just don't attack. Close this. Sure. Not worried about Clothis. I mean, it is annoying for my Loris, but at this rate, I'm just gonna buy a Loris to play him out as an attacker. No blocks. We just win the game. Oh, opponent. Now you get to see the power of Hammer Time. Got him. These games are quick and I need a diversion for a bit. Funny shit. Pretty funny shit. So when I get closer to this ridiculously... Yeah, it's tessellating. Okay. It's slowing my whole computer down there, so let's turn that off while I do this. Yeah, this is the dream right here. We have a turn to kill in this hand right now. Like we just, if he taps out, doesn't block this thing, or doesn't do anything about it. Alright, cool. We win. Turn to kill. I'll make sure and stream the quarterfinal stream. I'll probably play this deck. Or not the quarterfinals, the qualifiers, not the quarterfinals. And this deck is just gross. Yeah, I also had, like, the next turn, even if he'd blocked it, I had the combo kill next turn with Fling, or Thud. So if you get a hammer on, there's 8 creatures in this deck that if you get a hammer on that creature and it hits one time and dies, then you just win. And then there's also 4 Thuds and 2 Kazals. I have to take this hand. It's not the fastest because it's all tap lands, but holy shit. It's loaded up. So I could block here and do 11 damage, but I'd rather just do it. I'm gonna run out like this. Because now when this dies, he takes 11 damage to the face. And I just play another one. And attach the Colossus Hammer to it. And play a fighter class. And grab another Colossus Hammer. Or no, we'll grab a Shadow Spear. And now he can't attack me anymore. Sorry. Just absolute nonsense. Oh my god. All death touch creatures, and it doesn't fucking matter because when the guy you still take 11 to the face. And Sigarda's 8 is fucking busted with Hammer. It's like a shitty card in any other context, but if you have 4 Sigarda's 8, 4 Hammers, and all the other equipment enablers, it's like reasonably consistent. And it has a 3-card turn 2 kill combo. I mean, that's pretty good. And there's actually like multiple ways you can turn 2 combo. You could turn 2 combo with Sigarda's 8 or Resolute Strike. And a hammer, and either one, and you're fucking the creature that sacrifices itself. This is like, if it had one more land, it would be amazing. We keep 6 and put the fighter class back because we already got all the equipment we need, and then we just start it up. I'm not very confident about this hand. We need an enabler. If we get an enabler, the hand is bananas. We play Shadow Spear because we want to use it right now. We hold Colossus Hammer because we want to... okay, it's mill. Because if we get a Sigarda's Aid, we don't want to play our Colossus Hammer. Oh man, we had one on top, dude. Well, that's actually fine. Because now we just buy Luris. Attack. Decline. And then next turn we can play Sigarda from the graveyard. And then we're set up. Okay. Opponent does nothing. This is fine. This is absolutely fine right now. Come on, Sigarda's 8 off the top. Fuck, it's not, but... Alright, opponent. Hit me. This is his chance. He's got him 45 cards this turn. Alright. 2 and a bunch. A bunch. Our whole deck is like 1 mana cards. It's juicy. But we win next turn. I'll choose to do 44 potential damage to you. About to go make dinner too. I got my search nodes pretty much done for my Proctree, which is what I really wanted to get done. Next thing is to use that as the core of an randomization engine. I'm gonna keep this one. On the upside, there's a lot of upside here. All I need is an enabler. I have rabbit battery, which is useful. I'm gonna get a little bit of damage out of that, and it might be able to absorb some flak too. Oops. Perfect. Let's go. Okay. Sure. I just need this Fireblade Charger to die if we win. Thud would be amazing. Gotta respect it, dude. Oh my god. So now we just play this because we don't actually, like, he can't swing anymore. Because now if my Kako Scamp dies, he just, let's do Jammit Source. There's all kinds of shit going on here. Okay. But now you're in a lot of trouble because I can just swing with the 1/1 and you have to block it. Alright, well. Does it have lifelink? No. Like suicide hammer. Probably time for one more game, then I'm gonna go make some dinner. Or maybe get some dinner, I don't know yet. I did work out today, I'm not sure I wanna cook too. So we usually keep the hands that have the enabler and the hammer, but no creature, because in this hand actually does have a creature with fighter class. What? This. The nice thing about the rabbit batteries is we can fetch them with fighter class. It's very fancy. We're gonna have a big rabbit next turn. Are you, why did you not destroy Cigar's Aid? Are you kidding me? Oops. So he's just dead. Because I can do this. Dupe. 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 Just dead. The games are so fast, it really feels like you could keep getting games in before. It's just like, oh, I can get one more. And when on turn 3, we can get another one. Resolute Strike Kimba's Outfitter. This is like a borderline. I don't think I want this hand. It's too slow. This doesn't work on this. This can get my hammer, and I have this. So I do have the 1, 2, 3. Kimba's Outfitter, Fighter Class. No, but I can't play it like that because I can't play this before I play this. So I don't think so. This is garbage. There we go. We can work with that. Just don't want to see Thoughtseize. But it's probably turn 1 Thoughtseize. No, it's not. Alright, well. Oops, damn it. We get the opportunistic hit in for sure. Funny can probably kill the. Nope, he's dead. That's just mean. I like this version better than the like more complicated version. Like there's one that runs like you could strip. What you can do is you can basically strip the Resolute Strikes, or strip like a couple, and run Esper Sentinels and some other shit. I don't like that as much. Yeah, we fucks with this hand too. This hand's actually insane. We can attack with a 12-11 on turn 2 if he doesn't do anything about it. And then on turn 3 we can attack with an 11-11 and then thud the 11-11 and do 22 more damage. So we can attack 12 damage on turn 2 and then potentially another 33 damage on turn 3. Alright, big man on campus. Bro is AFK. Alright, well. Yeah, I'll keep this hand. The Resolute Strike opens up a different option. With the Resolute Strike off the top deck, I play the Charger instead, I'm pretty sure. Because if this guy plays another Death Touch critter, which is fine, he's going to block me and he's going to take 11. And then I'm going to play the Kimbas and equip that. No blocks. Sure. So this needs to be red. Red. Oops. Alright. The Sea Hammer. Resolute Strike. Swing for a 13. He blocks. Gains 2. Takes 13. And then next turn we can outfit or equip Thud. Dead? This is closer to like a combo aggro deck. It's not as resilient. The creatures aren't good by themselves. But certain creatures paired with the hammer are just like overwhelmingly powerful when that happens, to the point where it's like really like you're damned if you do, damned if you don't. Like you have a board full of Death Touch creatures, I attack you for 11 or for 13 damage with fucking Fireblade Charger. You block it, and then you get fucked anyway. So it's like pretty good. I think I hold this, and I think I put Gavalier first here. Actually, well, no, we have a Shadow Sphere. This might have been a bad keep, to be completely honest, but I'm gonna try for it. I think Gavalier into Fireblade Charger Shadow Sphere. And then the turn after we can equip Gavalier and go. Oops. Damn, that happens a lot, huh? That's why I don't normally play it like this. Scamp. Shadow Spear. I'll attack. I have Luris, he doesn't. This is Toxic and Death Touch. Sure. I will take the initial poison counter. I will do it. Now we're talking. Thinking. So what I'm thinking is, like, I could attack with a Cavalier, and then I could thud the Cacophony Scamp and kill the Fangbearer. But I think we just play out the board and then do nothing this turn. If my opponent mistakenly thinks he's on the aggression here, it could be bad for him. Okay. Sure. Three counters. Alright, you better kill me this turn, opponent. What's this? We're gonna block. Oops. Oopsie. Oopsie doopsie. Opponent told us to sacrifice a creature, and we were more than happy to do it. I was just trying to think about how I could get that guy killed. I was like, how do I get this guy to die before his next turn? And he did my work for me. Oops. It's kind of a do-nothing hand for the first returns, but we'll be set up to, like, potentially combo kill. Alright. Fighter class. Could be that I shouldn't have done that. Probably shouldn't have done that creature thing that I just did right there. But okay. Well. I'll attack. No, this isn't good enough. You need something. Like, if this had one enabler in it, I'd probably take it. If this had a hammer in it, I'd probably take it. Does that a fighter class in it? I'd probably take it. This, on the other hand, is insane. Insane. More insane. More insane. Oh no. I don't have a way to get the hammer on the rabbit right now, so I have to take the hammer. We could stall out here. There we go. Pass turn. You gotta kill us right here. And this is 3 toxic. This next turn we can just thud. Not gonna try to like swing or anything. Sure. Kapow. Bop bop. Keep saying I would get out. I want to get off, but I also want to keep playing till I lose. If this just had a mountain or a plains, it's like, oh yeah, there it is. It's insane. Bop. Probably bounce it. Alright. Just thinking about how this works out. Yeah, so we just do this. And then wait for him to attack and play another hammer and block. He's still doing ramp stuff. I don't think that's a good idea personally. Although it is Harrow. Now swing with the 11-11 and die. Got him. It's because he took that hit. Yeah, like we can work with this for sure. We just go Bugbear Charger, Aiden Spear. Steer, toxic one when it dies. Damn. Hammer off the top is the game at this point. Skrells. Come on. Okay, that's nice. That means we can play this. And then just looking for that hammer. And I wonder what's, I mean, that's pretty good. Thinking I can attach this to the charger. Thud. I mean, I don't need to do that. If I want to use the thud that way, I think we just thud kill this. Nope, no. Thud to kill this. Sacrifice this to kill this. Yep. This way. And then we send out another Kimba's outfitter. Next. No attacks. Intern. This is a fun deck. I like it. Okay. This lets him get it back at the end of each turn, right? No blocks. My turn. There it is. A little bit too late. But we did get there. This is a lot of damage right here. That's a lot of damage. I really want somebody to beat me. This is a 12, 11 on turn 2. And lots of backup. Shove. Oh. You didn't block that? And like this thing is made to die. Got him. Sometimes you just scoop to the 12-12 on turn 2. I mean, fuck. If you ain't got an answer, that's it. game. Now I'm installing. Stalling for time trying to find an answer. He's got a fucking, he's probably got the enchantment removal shit. Yeah, he just put one on top. However... Wait, fuck, dude. No wonder I've been winning every game I'm in fucking play. I thought I wasn't ranked. Oh my god. Freaking derp. I'm gonna roll with his hand. Got double hasters. It doesn't make any difference if you're in play or not. The deck just fucking kicks ass. We'll keep this. We just need white mana. So that's no. So that's not ideal. Although if we get white mana next turn, we can just kill the opponent potentially. Opponent's on red black discard, so I'm going to. Oh no, red black burn. No. I have the Resolute Strike in hand. I think I want to tap land, play Colossus Hammer here. Climb. And then if I get a white, we're just in business. I have multiple enablers, so I can handle the discard better like this. Fade. Alright. That's not the best. So now here's the question. Is it worth sacrificing now to get rid of his little derp? I don't think so. If we literally, like, if we don't get white mana, we're fucked. But if we get any white mana, that's ideally non-tap land white mana, we're in fucking business. Ah, it's madness. So your Fiery Temper is my scamp? Maybe? Or just me? Do the scamp. Oh, he just goes face. Damn. Kinda wish he'd gone on the scamp there. That would have been nice. Yep. Ouch. That hurts. That hurts. Okay. Well, shit. Now... we just take the hit. I mean, we can't block actually, huh? Alright, we're dead. He can spawn this and then copy it with the treasure, and I'm dead, so I just concede there. Perfect! Alright, I'm gonna go make dinner. I was waiting for somebody to beat me. It took like 30 minutes.